Hello everyone, let's solve the second question of weekly contest 241, and the question is minimum number of swaps to make the binary string alternate. So in the question you're given with the binary string S and you need to return the minimum number of character swaps to make the string alternating. And if it is not possible for us to make the string alternating, then we need to return -1 in that case. So first of all, let us try to understand what this alternating means. If the string is binary, then we know that there will be only two characters present in the string, either 0 or 1. So a string is alternating means that no two adjacent characters are equal. That is, no two adjacent characters should be 0, 0 or should be 1, 1. Example is given to you. For example, the string 0, 1, 0 is an alternating string. The string 1010 is also an alternating string, but the string 0100 is not an alternating string because 00 is present together over here. Also in the question it is given that you can swap any characters given in the string. The characters need not be adjacent. So now I hope you have understood the question statement. So I would highly recommend you to please try out the question on your own and then only proceed to the hint of this problem. So now I hope you have tried out the problem on your own. So now let's see how we can solve this problem on our own. So in this problem, first of all, let's try to check out the case in which we have to return -1. That is, let's try to check the cases in which it is impossible for us to make the string alternate. So for that, let's take a few examples. Let's say the first string given to us is this. Can we make the string alternating? Let's try it out. If we keep the first one as it is, and if we swap these 1 and 0, let's try to swap it. Still, it's not an alternating string. Again, let's try to swap this 1 and 0. 1, 0, 1, 0, 1. Oh yes, now it's an alternating string. Okay, so let's take another example. So this time, let's say our example is this one. Can we make this string alternating? Okay, let's try it out. This 0 is not at its correct position. Let's try to swap this 1 and 0. Yes, this means we can make this string alternating. Okay, so let's take another case then. Can we make this string alternating? Let's try it out. If we just swap this 1 and 0, then we will get 1, 0, 1, 1, 0. Okay, it's not alternating yet. Sorry, it should not be 0 at the end. It should be 1 only. So, yeah, we have swapped this 1 and this 0. Okay, so can we make now this string alternating? No, we can't make it because still we need one more 0 over here as well as over here to make it alternating. That is, there is a lack of zeros over here. Similarly, if we take this example, again, we can't make this string alternative because we don't have sufficient number of ones to make it alternative. So how can we get the point that do we have sufficient number of ones or not? So let's see. The count of 1 over here is 3 and the count of zeros over here is 2. In this example, the count of zeros is 3 and count of 1 is 2. But here, the count of 1 is 4 and count of 0 is just 1. And similarly in this case. So basically, if the absolute difference between the count of zeros and ones is greater than 1, in that case, we cannot make the string alternating. But if it is less than or equal to 1, then definitely we can make the string alternating. So we have concluded that point that if the count of ones and the count of zeros absolute difference is greater than 1, then in that case, we need to return -1. Okay, so we have found the impossible case where we can't make the string alternative. Now let's come to the case where we can make the string alternative and we need to find out the minimum number of possible swaps. So for that, again, let's take the examples. But before taking the example, let's see all the cases over there. So there can be three cases again if the absolute difference is less than equal to 1. The first case can be the count of ones is greater than the count of zeros. The second case can be count of zeros is greater than count of ones. And the third case can be count of zeros is equal to count of ones. So we have seen both the cases where count of ones is greater than zeros as well as count of zeros is greater than ones. Let's see these two examples again where count of ones is greater than zeros and count of zeros is greater than 1. So these are both of the examples. So in this case, let's try to make the first string as an alternative string. So let's say we keep the first character as 1 only. If we keep the first character as 1, then the second character should be 0. Then the third character should be 1. The next character should be 0 and the next character should be 1. So we have 3 ones and 2 zeros only in the final alternative string. Okay, so let's see another case. What if we keep the first character as a 0? If we keep the first character as a 0, then the second character should be 1. The next character should be 0. Next character should be 1. We can't take the next character as 0 because we have consumed all the zeros of our string. The next character can only be 1. So now this string is not an alternative string. So this means we have concluded that if the count of ones is greater than the count of zeros, in that case, your first character of the string should be 1. So if this was our original string, then the final alternative string that we want should be this one, where 1 is our first character. Okay, similar in this case. Now in this case, the count of zeros is greater than ones. This means 0 should be our first character. So we can see in the final string 2, we have 3 zeros and 2 ones. Okay, now let's see how we can find out the minimum number of swaps. So to find out the minimum number of swaps, we'll find out the wrong positions. That means we'll find out the positions at which the characters are placed at incorrect positions. So this 1 is placed at its correct position because in the final string we want the one to be here. But this 1 is placed at incorrect position because in the final string we want that 0 should be placed over here. Similarly, this 1 is at correct position. No need to worry about this. Also, if we have found one incorrect position, this means there should definitely be another incorrect position present in our string. So we are going to find that another incorrect position. This 0 is at correct position, but this 0 is at incorrect position. We want 1 to be present over here in the final string. That means there are 2 positions at which incorrect characters are present. Then we'll just swap these 2 positions to find out our final answer. So in the original string, we'll just swap this 1 and 0. So you'll get 1, 0, 1, 0 and 1 as our final answer. So if we found 2 wrong characters, then we just need to get 1 swap over here. That is, by traversing the whole string, you'll find out the number of incorrect characters to be present in the output, and then you'll just divide that by 2 to get the minimum number of swaps. Similarly, what if the 0 is our first character? In that case, again, this is at correct position, but we want 1 to be here in the final string. This means 1 incorrect position. Again, we want 0 to be here in the final string. Second incorrect position. This is correct and this is correct. 2 incorrect positions again. So number of swaps will be just 1. So these are the case in which either the count of ones is greater than zeros or the count of zeros is greater than ones. So we have to first of all find out whether 0 should come first or 1 should come first. Then we can easily find out the wrong positions. But there can be the third case too. What if the number of zeros is equals to number of ones? What if this is the case? Now, 0 should come first or 1 should come first? Both of them can come first in this case. Let's try to find out. We should have 3 ones as well as 3 zeros in the final string. Or we can also do this, 3 ones and 3 zeros in the final string. Both of them are alternating string. So in this case, we'll find out the wrong positions in both of the cases. We'll divide them by 2 and we'll find out the minimum among them to find out the minimum number of swaps. For example, in this case, if we try to find out the wrong positions, then 0 is at correct position with respect to this string. This 1 is at incorrect position. Now again, this 0 is at correct position. This 1 is at correct position. Again, this 0 is at incorrect position. And this 1 is at correct position. So 2 incorrect positions over here. So 1 swap will be taken to make this string equal to this string. Let's take the second case. What if 1 will be a first character? Then first character is incorrect, 1 incorrect, second is correct, third is incorrect because 1 should come over here. Fourth is also incorrect because 0 should come over here. Fifth is correct, but sixth is also incorrect because 0 should come over here. So 4 incorrect position, that means minimum 2 swaps will be needed if we want to make this string equal to this string. So we'll find out minimum among them. Minimum among them is 1. So this will be our final answer. So we have covered all the cases to find our final output. Let's take all the cases again. First of all, impossible case, in which the absolute difference between the number of ones and the number of zeros is greater than 1. In that case, we directly have to return -1. Second case was, what if number of ones are greater than number of zeros? Then 1 will be our first character, and keeping this in our mind, then we'll find out the wrong positions. After finding out the total number of wrong positions, we'll divide it by 2 to find out the minimum number of swaps. Now, what if zeros are greater than ones? In that case, again, 0 should be our first character. We'll find out the wrong positions and we'll divide the wrong positions by 2 to find out the minimum number of swaps. Now, the third case can be if the zeros are equal to the number of ones. In that case, both 1 as well as 0 can be our first character. We'll find out the number of wrong positions in both of the cases. We'll divide that by 2 to find out the minimum number of swaps in both of the cases. And we'll find out the minimum value among them to get our answer. So now I hope you can code this problem on your own. This problem was pretty easy for you. So thank you.